Today we're tasked with evaluating the function when x equals 2. The function is written right here with this equation. Evaluate simply means we're going to calculate what we can, and we know our x value is 2, so we're going to take that. We're going to put it in for this x value here. That would give us y equals 1 minus 2 plus 4. 1 minus 2 is negative 1, plus 4 would give us 3, so we get y equals 3, and we're finished with that question. Now this down here is a variation of the exact same question. You'll notice it says here evaluate, which means calculate. This is read as f of 2. Well, what does that mean? You can see down here that we have this, which is read as f of x, and the 2 is in place of the x right there. So this actually tells us a couple of things. You'll notice that this side of the equation is exactly the same as that side of the equation. The only difference between these two is that our y value has changed to f of x. Okay, let's bring a couple of things together. So our y value is f of x, and we have this f of 2 thing here. That tells us that we're going to plug in a 2 in place of the x. Over here, we plug in a 2 in place of the x, and we can see that this calculation ends up being exactly the same as that one. So these two questions are the exact same question. And we end up with f of 2 equals 3 when we calculate this. So we have our y value and our f of 2 value here. Okay, so let's talk about this. F of 2, or f of x, is simply a new name for our y value. So why do we have a new name for our y value if y was working before? Well, one of the reasons why we do that is because when we're finished here, we can see that we have plugged in our x value of 2. That information is still there for this notation, but it is not here. So our y value is 3, and we can see our y value is 3 over here, but this retains the information that we plugged in a 2 for our x value. The second reason we can see over here, when we use function notation, it gives us the capability to give things different names, which when we only have one equation, like with our last example, is not a big deal. But here we can see that we have 3 different equations, and we've called one of them f of x, the second one g of x, and the third one h of x. Previously, with our old notation, we would have said y equals 2x minus 5, and y equals x squared plus 3, and we would have called them all y, and then I wouldn't know which one we were talking about when we wanted to do some calculations. So with this notation, I can give information about exactly which one I want to work with when I ask the question right here. So I can be more specific with my notation. Remember, evaluate means we're going to calculate. This right here says g of 2. So I know, because of this notation, that I am looking at this equation right here, because this is named g and this is named g. So let's write this down here, g of 2. That means we're going to replace the x with a value of 2. So everywhere we see the x, we're going to replace it with a 2. And at this point, we just finish our calculations. So 2 squared is 4, plus 3 is 7. That gives us g of 2 equals 7, and we've done our calculations. Right here, f of negative 3, that tells us we're using the function that's called f. So we're going to come over here where we found our function called f. That negative 3 tells us in place of x, we're going to put negative 3. So we have 2 times negative 3 minus 5. 2 times negative 3 is negative 6. Minus 5 is negative 11. So we have f of negative 3 equals negative 11. The last one, we have h of 5, which tells us we're using our third function, which we called h, and we're putting a 5 in. So that's right here. We have h of 5. And then over here we have x in 2 different locations. So everywhere we see x, we're going to replace it with 5. That's right here and right here as well. So that we get 5 plus 5 squared. 5 squared is 25. Plus 5 gives us 30. All right. Now, one word of caution. I see a lot of students that want to divide this 5 because it looks like multiplication, but we are finished here. This together is a name for y. We never separate this notation here. We leave f of negative 3 together, g of 2 together, and h of 5 together. We are finished with all these calculations. Now, we might give the information kind of a twist so that we start with some different things and we have to find the value of x. So the question right here, I don't know what to put in for x, but I do know this information over here. Remember, h of x, this is a name for y, so I could write this as y equals 63. I know my y value is 63, and I know this is the y value, so I could put that 63 in for the y value, and that gives me an equation now that I can solve for x. So when we look at here, we know the y value. We're going to take that and we're going to plug it in for the y value over there. All right, finish this out by dividing by -7, and we get x equals -9. Over here, same thing. We know our y value. K of x is a name for y, so we're going to take that value, 18, we're going to put it in for the y, which is k of x right here. K of x goes in place of k of x. So we have 18 equals 6x minus 12. Let's finish solving this by adding 12. That gives us 30 equals 6x, and we'll finish it out by dividing by 6. And we now know our x value is equal to 5. So you have to pay close attention to the information that you know. If you know the x value, you plug that in and calculate. Or if you know the y value, you can plug that in place of the y and calculate. As long as you remember to put things in the correct place, you should be good to go. Thank you.